All right, here we go. All right, today we are talking about triangle similarity. Now, on Friday, we learned what was required to have similar figures, and we needed 3 pair of congruent angles, and we needed 3 pair of proportional corresponding sides. So just like when we were proving triangles congruent, there were 6 things that we had to figure out, and then we learned there were shortcuts. So same thing here for triangle similarity. There's a few shortcut methods that we have to see if triangles are similar. And so the first one we have here is angle-angle similarity, which means we need 2 pair of congruent angles. And if we have 2 pair of congruent angles, then our triangles are going to be similar. So we want to determine whether the triangles are similar by angle-angle similarity. And if yes, we're going to write a similarity statement, which is triangle is similar to triangle, whatever. We got to make sure we get those in the right order. Let's look at number 1. Looking at those 2 triangles in that picture, do we have some congruent angles? Yeah, give me some angles that are congruent. G and C. Okay, so angle G right here is congruent to angle C. Why are those 2 angles congruent?
Parallel lines.
Okay, so if parallel lines, what kind of angles are those? Alternate. Very good, guys. Alternate interior angles are congruent. Remember, they make that sort of Z shape. Parallel line, transversal, parallel line. So those are alternate interior angles, and they're definitely congruent. What other angles are congruent?
E and F. E and E.
I know what you mean by E and E, but that's not quite specific enough. DEC, right here, is congruent to GEF, but I knew what you were talking about. Why are those 2 green angles congruent? Vertical angles are congruent. Very good. Vertical angles are congruent. Again, writing these down just so we can remember them when you see them. All this stuff we learned first semester still applies. All right, so do we have 2 angles?
Yeah.
Absolutely. So we do have angle-angle similarity. Now, why is it that we don't need the 3rd angle?
Because it only says it only calls for 2 angles.
Well, you're right. So because we have that 3rd angle theorem, right? If we know 2 angles are congruent in a triangle, don't the 3rd angles have to be congruent? Yeah. Absolutely. Okay. Inigo, what you said, if it was a quadrilateral, we'd need 3 angles congruent. The 4th would have to be. You're absolutely right. Very genius. Okay, so we want to say triangle. Now, be careful how you order this. I'm going to say triangle DEC is similar to what triangle?
GFE?
No.
FE.
Okay, good. I did D, which has no markings, then E, then C. So D, green, red. So we're going to do F, green, red. So FEG. All right? Make sure you get those in the right order. Order matters. Let's look at number 2. We have 2 triangles here. We would call these overlapping triangles. We have a little triangle, LQP, and we have the large triangle, LMN. So, question, what angles do they have in congruent?
Q and N.
P, Q, L, and N, M, Q.
P, Q, L right here, and N, M, Q. Very specific. Love the wording there. All right, why are these 2 red angles congruent?
Oh, hello.
Are they corresponding?
Earthquake.
Corresponding is very, very good. Okay, so because of parallel lines, if parallel, corresponding angles are congruent. So those two angles are corresponding. They are congruent. What other angles are congruent? Tyler.
MNP to QPL. Wait, no. QPL.
QPL, yeah. MNP and QPL are also congruent. Also by corresponding angles. There's another angle that's congruent. Inigo.
MLN and QLP.
Yeah, MLN is angle L, and QLP also angle L. Angle L is part of both triangles, isn't it?
Yes.
It's part of the small triangle, and it's part of that large triangle. So that is the secondary angle there, that reflexive angle. It's in both triangles. Reflexive property. So once again, angle similarity. I'm going to go with triangle. LQP is, similar to triangle what? LMN. Very good. All right. Let's look at number 4. Number 4, we've got some angle measures here. I see 68 degrees and 68 degrees. Those are two congruent angles. Do we have congruent triangles? Do we know? Do we have congruent angles?
We don't know.
We don't know. Can we figure more out? Okay. Okay, 180 minus 68 minus 54. So I can do 180 minus 68 minus 54, and that equals 58. So this angle is 58 degrees. I could also figure out this other triangle, but I'm pretty sure they're not congruent. That one turns out to be 49 degrees. So these are not similar by angle similarity, at least, with what we're given, because they don't have two pairs of congruent angles. All right. What about number 5 here?
No, because we don't know if they're
Yeah.
parallel lines. Well, I guess maybe we do.
Yeah, we know 2
So we know two angles in the small triangle.
and
So both triangles have this angle in, right?
yeah.
Okay. So we need another. Can we maybe figure out?
Yeah.
Can we figure out angle B?
Oh, yeah.
Oh, yeah. I've got to figure out. How do we figure out angle B? 180 minus 91 minus 67. We get 22 degrees for that angle. That doesn't match that. Angle B doesn't match angle L there. What about the big triangle? Can I figure out angle M?
Yes.
180 minus 67 minus 25, and we get 88. All right, so they definitely don't have two pair of congruent angles, so again, these are not similar.
How is it snowing here? Sunny.
All right, what about number 6?
It snows and sunny outside.
What about number 6? We've got a pair of congruent angles. Is there another pair of congruent angles?
Yes,
Which ones?
YXZ and PXQ.
Good, YXZ and PXQ, my green angles here. Why are those green angles congruent?
Vertical.
Vertical angles are congruent. Good. So we have angle similarity. I'm going to go with triangle PXQ is similar to triangle ZXY. Very good. I started with the single arc mark, then the double, then the plane. So single, double, plane. So ZXY. All right. Questions on angle similarity? Fine, good. Okay. So we also have another shortcut method here. Side similarity. So similar figures. Are the triangles going to have congruent side lengths?
No.
No, they're not, because they're not congruent triangles. However, the sides should be proportional. They should have the same ratio. So we're looking for our corresponding sides proportional? That is the question here. Are corresponding sides proportional? So we need to figure out which sides match up, all right? Which sides correspond. And you can see here in number 7, these triangles are oriented in the different ways. However, does it make sense to you that if I start with the smallest side length, shouldn't that correspond with the smallest side length in the other triangle?
Yeah.
Yes. So we're going to go comparing small to small. So I'm going to compare 9 over 14. And this is kind of nice. We can use our trusty rusty calculators here. 9 over 14. And I get 0.6428 crazy. 0.6428 yada yada yada. And I want to compare another pair of sides. What's another pair of sides I can compare? NR, so this is now our second smallest side. NR and SE, okay. So 13.5 over 21. Let's see. 13.5 over 21. Ooh, same ratio. 0.6248. Yada, yada, yada. All right, and comparing my last ones. Yep, KR and SD. So 20.25 compared to 31.5. 20.25 divided by 31.5, and we get the same ratio, 0.6428. So, do they all have the same ratios of sides?
Yes.
Then they have side similarity. And I can say triangle KNR is similar to triangle DES. YES. It's so funny, honey. Okay. Okay. No. Oh, yes. Okay. All right, let's look at number 8 really quickly here. On number 8, these are overlapping triangles. So I see here I have a small triangle, triangle WVX, and I'm going to go ahead and separate these two triangles. I don't have to draw a beautiful picture, but just to make it nice and clear, here is my large triangle WYU. And how long is side WY? No, 21, thank you. And YU is still 42. And WU is how long? 28. Okay. So now I've drawn out my triangles. I think that's going to help me figure out my corresponding sides a little better. My smallest side here is side 15. What side should I compare that to? 21. All right. 15 over 21. Let's see. 15 over 21 is 0.714. Okay. And I want to compare which side next? 30 over 42. All right. 30 over 42. Let's see. 30 over 42 is 0.714. Okay. Do you want to step out? Because it's loud.
Yeah, it's really annoying.
It's loud, dude. All right. And then last. Good. 20 over 28. And again, I want to see if they all have that same. Oh, yes, they do, which is 0.714, yada, yada, yada. So you can see I just wrote them all as equal. All right, so they do have side similarity. Triangle WXV. WXV is similar to triangle WYU. Very good. Okay. All right, questions so far?
No.
Okay. So on number 11, Number 11, do we have enough information?
Number 11, do we have enough
Yes.
information? No. Wait, actually we do, because they are both.
Yes.
They're right angles. Yes, right angles. We're gonna have to find it, but we have.
We're gonna have to find the information, yeah. So, because they are right triangles, what theorem can we use? Pythagorean theorem. A squared plus B squared equals C squared. We need to use the Pythagorean theorem to help us find our third side in both of these triangles. There's our longest side, 13. I'm going to give this a B. And I'm going to solve for B here. Leg 5 squared plus B squared has to equal 13 squared. Will you go ahead and solve that?
Twelve.
B equals 12. That is a Pythagorean triple. 5, 12, 13 is a good one to know. What's another Pythagorean triple?
2, 3, 4.
3, 4, 5. 3, 4, 5. 3, 4, 5. 5, 12, 13. Okay. And then I need to find which side on this triangle? Hypotenuse. The C, the hypotenuse. All right, so then we have 9 squared plus 21.6 squared equals C squared. Yes, 9 squared plus 21.6 squared. Guys, 547.56 equals C squared, and I can take a square root and get 23.4. 23.4. Okay. Now that I have my third side, which we could do because they were right triangles, now I can check my proportions. Which side should I compare? 5 over 9. 5 over 9. All right, let's see. 5 over 9. 0.55555. Okay, what else can I compare? All right, 12 over 21.6, good. Let's see, 12 over 21.6. Hey, 2 for 2. What's the last one? 13 over 23.4. Let's see if that works. 13 over 23.4. Yes, it does.
I knew it.
There, 0.55 repeating. That works. They all have that same crazy ratio. So, triangle, I'm going to go ZYX. ZYX is similar to triangle RW then V. Yes, RWV. Good job. All right, questions so far?
Nah.
All right. Couple more here, and then we'll be done. Almost done. All right, last one, we have angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Really important, side-angle-side similarity. The angle must be between the two proportional sides. The angle must be between the two proportional sides in order for side-angle side to work. So let's look at number 13 here. Do we have a pair of congruent angles?
Wait, we have FEG and SER.
Good. Yeah, why are those angles congruent? Vertical angles, very good. Okay, so now that we have congruent angles, and we can see that the angle is between two side lengths, that's good. We still need to see if our sides are proportional. So let's see, I'm going to compare 6 with what? 6 with 24. Again, smallest number to smallest number. 6 over 24 is 0.25. All right. And then I can compare 12 with 48. 12 with 48, which is also 0.25. So they are proportional by side, angle, side. So we have triangle, I'm going to go RES, is similar to triangle FEG. Very good, FEG. Let's look at number 14 really fast. Do I have a pair of congruent angles?
P. No, wait.
JFS and PFY. Very good. Again, vertical angles are congruent. Does that help me here?
Yeah.
Do I have side, then angle, then another side? No, side, angle, side. I would need to know those two sides in order to use side, angle, side. Okay? Right. If they gave me J and Y, then I'd have side, angle, side, and that would be helpful. Do you see the difference?
Yeah.
Okay. Last one, number 15. Do we have congruent angles?
Yes.
Angle M and that other side of P there. What kind of angles are those? Corresponding. Very good. And we see side, angle, side, side, angle, side. We've got those sides, so let's compare. Let's see, 36 compares to 22. All right, what is that? 36 over 22. All right, and then what else do we need to compare? 54 over 33. Good. 54 over 33. 54 over 33, and we get 1.636 for both of them. They match. 1.636, yada, 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 they match. They are proportional. So I'm going to say triangle CMP is similar to what? RPQ.
RPG.
All right. Do you have questions for me?
Chill out.
All right. You guys have Delta Math. Please don't forget to turn in your homework from Friday. Good.